Now, guys, below in question 1 we can see a graph of the function. It's a cubic function. How do I know, even if the formula wasn't there, how do I know that's a cubic function? 2 turning points. Cubic functions have 2 turning points. Quadratic functions, 1 turning point, okay? Now, use your graph to find the following. Find the values of x. Now, is x an input or an output? Inputs. Find the input values when the output values are 0. When is the output value 0? Basically, when is y equal to 0? We have -1 and 2. Is that right? The y value is we're drawing these out, Cameron, yeah. The points would be this would be -2, -16. That means when you have an x value of -2, you have a y value of -16, and this one here would be -1, 0. When you use an x value of -1, your output value or y value is 0, and it's asked me when are the output values 0. I know it says what are the values of x. So we're specifically only asking for the x value, not the y value. So it's x equals -1 and x equals 2. Find the coordinates. Now, when you see the word coordinates, what does that mean? That both of them, the x value and the y value. So what are the turning points here, guys? Turning points, anybody? 0, 4, known as the local maximum or the maximum turning point, and the other one? 2, 0. Not so bad. Find the local maximum and minimum values. What does that mean? I would have tried to beat you into this on Monday. It's just referring to the y values only. So the local maximum is 4, while the local minimum is 0. Everybody right with that? Local maximum is 4, local minimum 0. Okay, it just refers to the y values. Now, estimate f of 3.5. What does that mean, f of 3.5? What's the input? The input is 3.5. Okay, so are the inputs the x values or the y values? The x values. You go up to 3.5, which is here. You go all the way up, and then you go across, and then you roughly get 10 or 11. Is that right? So 10 or 11. Could anybody think of a cheat way to do that? Put it into the calculator and go up in 0.5s instead, and you can find out quite quickly, okay? Find the values of x for which f of x is decreasing. What does the word decreasing mean? You're going down a hill. So when you travel left to right, you're increasing, you're flat. Now you're decreasing, you're flat again, and then you're increasing. That makes sense? When you're on your way down, going left to right, you're decreasing. When you're on your way up, you're increasing. So where do we start decreasing, guys? The x value of 0 all the way down to an x value of 2. How do you write that? Well, if it starts at 0 and ends at 2, we want all the values in between. So we can write less than or equal to x, less than or equal to 2. Yeah, it's technically just less than then, isn't it? Because flat would not be decreasing. So what Oscar's saying there is that, see, actually at the turning point, you're going directly across for a split second. So you're technically not decreasing. So it's 0 less than x less than 2. All the numbers in between 0 and 2, you're decreasing. Estimate the values of x for which f of x equals 2. What's the difference between f of x equals 2 and f2? Anybody know the difference? The top one is y equals 2. Find the x value. The second one is x equals 2. Find the y value. Okay? So, if you know the number that's in here, it's find the y value. If you don't know the number that's in there, it's find the x value. Okay? So, it doesn't tell us what's there. It just tells us x is there. That's not a specific number. So all I know is the y value equals 2. Go up to where the y value equals 2. Where does the y value equal 2? Halfway. Now there's a couple of answers, isn't there? Do you see there's a couple of answers? Go through y equals 2. Be around here, wouldn't it? And how many times do we hit the line? 1, 2, and 3. What are the 3 answers we got? Minus 0.7, 1, 2.7 or 2.75. Is that okay? You draw a lateral line going straight across. More or less did that one the last day, did I? Is that alright, or is there any question you want done on it? Question 2? Grant. Okay, this one here. Graph this function. Did I? I'll do question 4 first, okay, because I don't have 3 drawn yet. Okay, everybody have question 4 in front of them? Can you give me the numbers? So, this case, guys, what we're going to do is, see the way there's 0.5s on, see the way there's a 0.5? We're going to go up in the step of 0.5 instead to make sure that we cover 2.5 and 3.5. So what I'm going to do is press mode 2x squared, 2x cubed minus 3x squared, wrong question, 4. Then minus 12x plus 4. And we're going to start at minus 2.5. We're going to end at 3.5. We're going to do a step of 0.5. And look, we have all these points here, don't we? So you tell me minus 2.5, 16 is grand. What's the next point then? 0. After that? 0, 11, yeah. 4, minus 9, minus 16, minus 5, and 11. Okay. Now, you can see here that all these points are actually drawn out. There's your first point, your second point, your third point, your fourth point, your fifth point all the way down here, sixth point, the lowest value, and your 7th point. Is everybody happy with that diagram there? We good? Okay, I'll probably try and make it a bit more manageable. Sorry, get it better. It's too big to have a look at, really. There we go. It's a bit more manageable now. Okay, everybody happy enough with that? Okay, what are the questions we're being asked? Write down the coordinates of the local maximum and local minimum. Keyword? Points. If you ask for points, you're asked for the x value and the y value. Is that right? So what's the x value and the y value? Yeah. 2 minus 16. I'm going down in 2, so you're right about that being minus 16. Okay, that's your 2 turning points. The maximum being the top one, the minimum being the bottom one. Okay, what's next then? Use a graph to find the values for which x is decreasing. When does it start decreasing? The decreasing region is here. There to there. That's the decrease region. It's on its way down. So where does it start? Yeah. You're dead right. It starts at minus 1 and it ends at 2. That can be written as minus 1 less than x less than 2. All the numbers between minus 1 and 2. Okay, be cool with that. Now, once we cleared that part up, what we can do next is, what's the next question after that? F of x equals 0. Where's that, guys? So what's equal to 0? The y value is equal to 0. So this point here, and this point here. So what values would you give them? minus 2 is the first x value. The next one, 0.3 is a good choice. And after that, 3.2. Everybody alright with that? Okay, so the answers would be minus 2, 0.3 and 3.2. Because it's referring to the x values, not the y values. Okay, moving on. This is question 5. Now, question 5 is what some of you were asked me about earlier on. And what we can do here is we put this into the calculator. Everybody happy enough with doing the calculator part? It's reasonably easy. Actually, I can do it pretty quickly here. Have half the work already done. Just change that to a 4. Then change the last one to a 5. Okay. From minus 2 to 4, is it? And it's step of 1 this time because we don't need any 0.5s. We get the following graph with the following points. This graph is drawn here. Make it slightly smaller. Can't quite see everything. There you go. Okay. Now what we asked about this. Write down the coordinates of the maximum point. Where's the maximum point? 0, 5, and the minimum. Oh no. It turns out it's not the minimum point, which is interesting. So, to be fair to you guys only drew it every dot. So some of you would have had something like this. Would have been a bit. It would have been a bit tight though, wouldn't it? To turn. So if you suspect that you're turning a bit sharp, what's a good idea to do? Not necessarily make it bigger, but what you should do is you should go back here at the very beginning, and instead of doing it in steps of 1, do a step of 0.5. And what the step of 0.5 will do is when you go to the difficult part, the difficult region is in between 2 and 3. 2 minus 3, 2.5 is minus 4.3, and then 3 is minus 4. It gives you that extra point to help you correct the curve. So in a lot of cases, this key point here is that you might go up in 0.5s just to give yourself a bit more resolution on your diagram. A couple more points here and there make the diagram a lot easier. So me knowing this now would have put the extra point here, while you guys would have skipped across it. Just be aware, if it looks a bit sharp, go back to the calculator, enter in 0.5, and just check that, am I meant to go below this, or am I correct in what I was thinking? Okay, is that right? Alright. So, now we have this point, as it turns out, we have to estimate it, because we don't actually have to estimate it, because we actually know what it is. It's minus 2.5 and 4 point. Plus 2.5 and minus 4.4. Now, if you did it by graph, you could just say, look, that's 2.5s halfway between the two of them, go across, and you might say minus 4.4 that way as well. Now, use your values to estimate the values of x for which f of x equals 0. f of x equals 0, guys. Where are they? Minus 1, 1.4, and 3.6. Okay, now here's the hard one. Use your graph to solve the equations x cubed minus 4x squared plus 2 equals 0. That's not a quadratic, is it? And it says use the graph. Why would it say use the graph? Is there any similarities between this one here and this one here? Yeah, and you see this is the y value, isn't it? That's how we calculate the y value. We put in an x value and we use that formula to calculate the y value. Would you agree with that? Okay, so what I'm going to do is I'm going to force this equation here. I'm going to force it to look exactly like the old one. So how much is it short? It's 3 short, isn't it? So if I were to add 3 to both sides, would that affect the equation? If I add the same number to both sides, it doesn't affect the balance of the equation, correct? So when you get a question like this and it looks similar to the graph you just drew, turn it into the graph you just drew, but make sure whatever adjustment you do it to both sides. So as an example, something like this. I'd say x cubed minus 4x squared plus 5. I add a 3 onto the left, which means I have to add 3 onto the right. And what does this say? What's this mean again? That's the y value equals 3. That's a fancy way of saying f of x equals 3. That's a fancy way of saying that. Okay, so what you do is you draw a line going. You draw a line going straight across y equals 3. Where is y equals 3? Anybody? Y equals 3 is here. And where are the points where it hits? 1, 2, and 3. So what are the 3 points? Minus 0.6, 0.8, and 3.9 or 3.8. Where is that? It's difficult though, isn't it, that one? Alright. Next one. 6. On the same axis, what time am I at? Okay. On the same axis and graph, draw the two of these functions. I'm assuming you can all... Oh, I forgot the second one, didn't I? Just give me a second. I have here, guys, is a graph of the cubic function with the line going straight through it. Everybody cool with that? And what we're going to look at is use your graph to estimate the values of x for each of the following. What's the first question asked me? If it says f, is it talking about the curve or the line? If it says f in the question, is it talking about the curve or the line? F refers to the curve, G refers to the line. So f of x equals 0. Where is the curve's output equal to 0? Well, 2, minus 2, 2, and 3. Everybody alright with that? Minus 2, 2, and 3. Okay, next question. Where is f of x equal to 12? Where is the output of the curve 12? Well, if I draw a straight line through 12, you can see it happens how many times? 3 times. Once is minus 1, twice is 0, and the third time is 4. So minus 1, 0, and 4. Everybody got that? Okay. Now, when is f of x equal to g of x? When does the curve equal the line? G of x stands for the line, f of x stands for the curve. Is it asking for x values or y values? Find the values of x for which the following happens. So it's asking specifically for the x values. So where does the curve equal the line? There's 1, there's 2, and there's 3. But what are the x values for when this happens? Minus 1. What's the other two? Minus 1, the second one. 1, and the third one? 3. Okay, that's done. What about the next one? When is the curve bigger than the line? When is the y value of the curve bigger than the y value of the line? In effect, when is it taller than it? So what we're looking at is, when is the curve taller than the line? I would argue that it is here. And here. So x bigger than 3, bigger than 3, and in between minus 1 and 1. Alright, guys.